In this video, we are going to learn how to define and classify special types of quadrilaterals. So first, what is a quadrilateral? So a quadrilateral is going to be any four-sided figure. Now, to specialize that, remember that you cannot have arcs or circles as part. So think of it as a four-sided instead of a figure. We could say it is a four-sided polygon. So any four sides will create a quadrilateral. But remember, you cannot have an arc. This would not be considered a quadrilateral. Now, we have special quadrilaterals. For example, the three types would be a parallelogram, in which case you have two pairs of opposite sides that are parallel, hence the word parallelogram. Then you have a trapezoid, which is where you only have one pair of sides that are parallel. So one side would be parallel, but the other pair would not. And then you have a kite, in which there are actually 0 pairs of opposite sides that are parallel. Now, to specifically talk more about parallelograms, there's a couple of things, characteristics that you have. So in a parallelogram, we already know that opposite sides are parallel based off of the definition. However, a few more things can be denoted, in which case that one, opposite sides are also equal. So not only are they parallel to each other, or in this case, parallel to each other, but opposite sides are also equal to each other. So for example, if this is 5 centimeters, then this is 5 centimeters. The other thing to note is that opposite angles are equal. So if this is 100 degrees, then its opposite angle is 100 degrees. So those are additional characteristics of a parallelogram. Now you can even break special parallelograms further by a rhombus, a rectangle, and a square. So a rhombus has all of the characteristics as a parallelogram, opposite sides equal, opposite angles equal, plus all sides are equal. So if this is 5 centimeters, and this is 5 centimeters, and this is 5 centimeters, then this is 5 centimeters. In a rectangle, again, it has everything that a parallelogram has: opposite sides parallel, opposite sides equal, opposite angles equal, plus all angles are equal. So in a rhombus, you have all sides equal, but in a rectangle, you have all angles equal. And because a rectangle is a quadrilateral, which is 4 sides, then we can find the sum of the angles by doing our formula 180 times n minus 2. So if we do 180 times 4 minus 2, we would get 180 times 2, which is 360. So if we know all the angles should add up to 360, and we know that they're all equal, if you divide by 4, that is how you reach the fact that all of the angles of a rectangle are 90 degrees. And last, a square. A square has everything the parallelogram has: opposite sides equal, opposite angles equal, plus it basically has everything that a rhombus and a rectangle had. All angles are equal. You have the 90 degrees in every angle. And all sides are equal. So if this side's 5, then this side's 5, then this side's 5, and this side is 5. Next, we spoke at the beginning where you have a parallelogram, a trapezoid, and a kite. So now going to the trapezoid, we have one pair and only one pair of opposite sides are parallel, and we call them the base. So the sides that are parallel we call base, and then the legs are the segments that connect those two bases. Now there is one special trapezoid that we can talk about, which is isosceles. Again, you have one pair of base sides that are parallel, but the other two sides, these legs, are equal. So if this is 5 centimeters, then this is 5 centimeters. And also, where we talked about the legs being equal, the base angle pairs are equal, meaning if this is 100 degrees, then the other base angle to that is 100 degrees. Not opposite angles like a parallelogram, but the consecutive base angles. So if this base angle was 80 degrees, then this angle would be 80 degrees. And the last quadrilateral is a kite. Now, there are no sides parallel. However, they do have some special characteristics themselves. Adjacent pairs, meaning sides that are next to each other, they are equal. So if that's 5 centimeters and this is 5 centimeters, and then if this is like 11 centimeters, then this is 11 centimeters. And they have one pair of angles equal. So if this is 100 degrees, then this pair is 100 degrees. Only this pair are equal. The opposite pairs are not going to be equal. Okay, so to recap all of these characteristics. So you start with the quadrilateral. The only thing that we know is that it is a 4-sided polygon. Next, you can create special quadrilaterals, which is this row. It can be a trapezoid, a parallelogram, or a kite. And then a trapezoid can go one step further to be specifically an isosceles trapezoid. And then for parallelogram, it can break down further into special parallelograms, in which case you could have a rectangle where all 4 angles are equal. You can have a rhombus where all 4 sides are equal. Or if you think about if a rectangle and a rhombus got married, it would create a square. All the angles will be equal, just like a rectangle. All the sides will be equal, just like a rhombus. So if you think about what the characteristics are, you can say, for example, an isosceles trapezoid has all the characteristics of a trapezoid, just like the rectangle has all the characteristics of a parallelogram. So if you're moving up the chart, it will have all the characteristics of above. If you move down the chart, a parallelogram is a rectangle if all the angles are equal. So you can sometimes move down the chart, but you will always be able to carry the characteristics from above the chart. Just like a parallelogram has all the characteristics of a quadrilateral. A rhombus has all the characteristics of a parallelogram. So pause the video to attempt to answer this question and then hit resume. I'm a quadrilateral with only one pair of parallel sides. That is a trapezoid. Next, pause the video and then hit resume. I'm a parallelogram with all angles equal. That is a rectangle. Or it could be a square, but we don't know if all the sides are equal. So that's why this part right here, we wouldn't necessarily say because we don't know more, but we do know that it has to be a rectangle with all the angles are equal. Next, pause the video and then hit resume. No opposite sides that are parallel is a kite. Okay, pause the video again. Okay, all angles and all sides, that is going to be a square. Okay, now for this one. So what we're going to do is we are going to draw this quadrilateral. And I don't really know how to draw it, so I'm just going to create basically a quadrilateral. So, okay, I got 4 sides. Wherever I start, I have to go in order. It doesn't matter if I go to the right or if I go down. So if I go T, U, and then we got to follow it around V and then W, you have to write them in order. And now let's see what it says. TU is equal to VW. Okay, here's TU, here's VW. They are equal. We also know that UV is equal to WT. So I can say that those are equal. Okay, automatically opposite sides are equal. So we know it's automatically a parallelogram. Now let's see what else we know. We know that angle T is equal to angle U is equal to angle V is equal to angle W. That means all of the angles are equal. And where do we see all angles equal? In a rectangle. So therefore, I can specifically say that I'm a rectangle. So pause the video and attempt this one and then hit resume. Okay, so I'm going to draw 4 sides. It looks like a rectangle, but anyways. All right, I'm going to go V, W, X, Y. I decided to go this way, but wherever I went, you have to follow it all the way through. All right, VW is 10, WX is 18, XY is 10, and YV is 18. Okay, opposite sides are equal. We know it's a parallelogram, at least. Next, we also know that VW and XY are parallel. And we know that VX and YV are parallel. Okay, that still is only showing parallel. We do not know anything more, so therefore we will stop at a parallelogram. Now, could it be a rectangle? It possibly could be a rectangle. But again, we do not know anything else, and so we cannot go any further. Okay, pause the video to attempt this one and then hit resume. All right, we have F, G, H, I, but I don't think that should have been a VW. Let's see. F, G, H, I. All right, they said that FI and GH are equal. So I'm assuming this is supposed to be an FG. FG and HI are equal. Okay. We know that opposite sides are equal, but that's all we know. We do not know anything else. So the only thing that we can call this is a parallelogram. Now, if we say that this is a parallelogram, then we can automatically find all of these variables. So for example, if this side is 7, that means B must also be 7. If this side is 12, that means A must also be 12. And if this angle is 112, that means this angle is 112. Now, if this is Y, then this is also Y. And we know because it's a quadrilateral, it has to equal 360 degrees. So I can add all these together. 112 plus 112 plus Y. So I'll get 224 plus 2Y. And if I subtract, I'll get 136 equals 2Y. And then I divide by 2, and I will get 68 for Y. So therefore, we know that Y is 68 degrees, which means this Y is also 68 degrees. Next, using the properties of a parallelogram, we know that opposite sides are equal. So we can take 3A minus 4 and set it equal to A plus 2. I'm going to subtract A from both sides, and I'm going to add 4 to both sides, and then divide by 2, and I know A. And now I can do the same thing with B. B plus 1 equals 2B. So I'm going to subtract B from both sides. 2B minus 1B is B. So therefore we know that B equals 1. So pause the video and you attempt this one and then hit resume to see the answer. So in this case, we know that opposite sides are equal to each other. So I'm going to set it equal. So I have 4x minus 1 equals 3x plus 6. I'm going to subtract 3x and I'll get 1x. And then I'm going to add 1 to both sides and x equals 7. I can do the same thing with 3y plus 1 equals 4y minus 2. So 3y minus 3 equals 4y minus 2. I'm going to subtract 3y and I'm going to add 2. And so y equals negative 1. And last, to attempt to figure out the quadrilateral for this, again, we can do a couple of things. We can look for parallel, which means do they have the same slope? Or we could also look for the sides. So let's go ahead and look at the sides. So I need to figure out the length of QR. So what I'm going to do is I'm going to draw a right triangle to help me find this length of the hypotenuse. So 1, 2, 3. So I have 4 from there to there and 2 from there to there. 4 squared plus 2 squared is going to give me QR squared. 16 plus 4 is 20. So to find QR, I have to take the square root. So I know that QR is the square root of 20. So I need to do the same thing with TS. So I'm going to draw a right triangle. Same thing. I get 4 and I get 2. Automatically I know that's going to be the same thing then. 4 squared plus 2 squared gives me ST squared. So again, I get the square root of 20 for ST. Now, so we know that these opposite sides are equal. Now we got to check for the others. So now I'm going to do RS. So I'm going to draw a right triangle. This is a 1, 2, 3, and this is 4. So therefore, to find RS, I'm going to have 1 squared plus 4 squared equals RS squared. That's going to give me 17. So therefore, I'm going to get the square root of 17. Now I'm going to do the same thing with Q and T. If I was to draw a right triangle, I would have a 1, and this is also a 4, so the same thing is going to happen. 1 squared plus 4 squared equals QT squared, which gives me 17, which gives me the square root of 17. So we know that opposite sides are equal, so we know it's a parallelogram. That we got. Now, to find if it's a rectangle, you're looking to see if this right here would be 90 degrees. Okay, so you're looking for if this is a 90-degree angle. If it's a rhombus, then all sides are equal, which that does not happen. You have the square root of 20 and the square root of 20, but here is the square root of 17 and the square root of 17. Since all sides are not equal, it is not a rhombus. So if we check rhombus, it is not a rhombus. The only thing we can check is if this is 90 degree, which means we are wanting to know, are consecutive sides perpendicular? Because you learned that perpendicular means 90 degrees. So if I was to find this slope of QR, so the slope of QR, meaning if I go to Q down to R, I would go down 2, so it's negative, and go over 4. So I'd get a negative 1/2 for the slope. If I wanted to find the slope of RS, So I would be going from S up to R. So I would go up 4, which is positive, and I would go over 1, which is 4. These slopes are not perpendicular. Don't forget, a perpendicular means that it is the negative reciprocal, meaning if 2/3 was a slope, then -3/2 would be the reciprocal slope, the negative reciprocal. So these are perpendicular to each other. You flip the number and you take the opposite sign. These are not that, so we know that it is not a rectangle. So if we checked for rectangle, we know that it is not a rectangle, which means it can only be a parallelogram. So here, pause the video and attempt this on your own to see if you can figure out what type of quadrilateral it is. So if we were to draw out we are looking for what type of quadrilateral this is. So instead of doing the actual Pythagorean theorem, we could actually just do the slope. So if I was to go from P to S, I would go up 1 and over 3. So that would be the slope. If I was to go from F to T, I would go up 1 and over 3, which means since they have the same slope, that means we know that they are parallel. Now let's check the other two. P to F, I would go down 1, 2, 3, 4, and go over 1, 2, 3, 4. So I would get -1. And then if I did S to T, I would go down 1, 2, 3, 4, and over 1, 2, 3, 4. So I would go down 4 and over 4, which is also -1. Again, same slope. And so therefore, we know that those are parallel. So we know it's automatically a parallelogram. But we do know that it's not a rectangle because the slope of 1/3 and -1, they are not negative reciprocals, so we know it's not rectangle. We also can just look at it and see that it's not a rhombus. We can clearly tell that all 4 sides are not equal. So this would only be a parallelogram.